Hi, welcome to our next set of notes talking about exponential functions. Real quick, I just have a couple of silly jokes to share with you. First, what did the mother buffalo say to her boy as he was leaving? Bison. What kind of snack do little monkeys have with their milk? Chocolate chimp cookies. And what did the teddy bear say when he was offered dessert? No thanks, I'm stuffed. Alrighty, let's go ahead and get into today's notes. We're going to start by defining exponential functions, and really, we're not defining it. We're going to write down the function for it. So we're going to go ahead and write in f of x is equal to a times b to the power of x. Okay, so just how like linear functions had something like slope-intercept form, exponential functions have something similar. So this is their function form. We're going to know that a is your initial amount or initial value, so those words are interchangeable. And then we'll go ahead and write in how b is your constant ratio. Okay, just a couple of things that I want to talk about is a has to be a non-zero number. Or basically a can't equal 0. Okay, because if a equals 0, then your function does not work. B has to be a value greater than 0. And b cannot equal 1. Okay? The next thing that we're going to define is a new math vocab term called an asymptote. This is a line that the function approaches but never reaches. Okay, and it is a line that we don't draw. We will just see it with the graph. Problem A and B, where we have this graphing stuff right here, we're going to do next time in class. So make sure you are bringing a graphing calculator or your Chromebook to access Desmos, okay? That's when we'll go over these key features at the bottom as well. Let's go ahead and turn the page. And we're going to go ahead and write exponential functions. That's what we'll practice right now in class or in this video. So for this one, to write exponential functions, what we have to do is figure out that constant ratio, okay? So what value from 4 to 12, how do we increase? And so since it's a constant ratio, we're going to know that it's by multiplication. So, and then if we think it's times 3, well, then we'll go ahead and keep checking. 12 times 3, we do get 36. 36 times 3, we do get 108. So we see that our constant ratio, okay, is going to be to multiply by 3 each time. Okay, so a couple things that we're going to write down is first, whenever we are writing these functions, so again, real quick, we're writing it in the form f of x is equal to a times b to the power of x. Okay, a is our initial value, so I'm just going to go ahead, initial value, initial amount, same difference. It's when x is 0, what is y, also known as your y-intercept. Then we have our constant ratio, which is 3. And then we'll go ahead and put this into our function. So it is going to be our initial value. And so a lot of times you'll see the constant ratio, in parentheses to the power of x. And that's especially important when we're working with fractions. Okay, let's go ahead and try the next one. So again, we see our x coordinates are increasing by 1. Our y coordinates, how do they increase? And that's what we have to take a look at. And notice that each one of these do increase by 5. And so when x is 0, what is y? This, again, is known as our initial value. And this time I'm going to write down the word value. And it is 1. Our constant ratio, we multiply by 5. Then we'll go ahead and put this into our function. 1 times 5 to the power of x. A lot of times when you have the number 1, you'll see it written just like that, where it's just f of x equals 5 to the power of x. Okay, now we can also do this with graphs. Okay, so with our graphs, what we're going to do is just, again, kind of come up with a small table finding out these values. Okay, so I think I'm just going to do it right here on the side where I have my x coordinates, my y coordinates. Okay. When x is 0, my y looks like it's right around here. So I'm going to go with 1.5. When x is 1, I'm right here. It looks like I'm right around 0.6. And then when x is 2, this one's a little bit harder to figure out. So I'm going to just kind of wait on that. But again, if it was easy to identify and write down, we would be writing it down. And now we can use this table just like how we used it on the previous 2 problems. So let's go ahead and start by writing down our y-intercept. Our y-intercept is 1.5. Our constant ratio, that's what we have to figure out. And for this one, just like how we did for geometric sequences, we use the previous term we use the term and divide it by the previous term. So 6/10 divided by 1.5 or 1.5, we get 4/10. Okay. And then let's go ahead and write this in our equation. So f of x is equal to 1.5 4/10 to the power of x. Okay? We could always write it as a fraction as well. 4/10 simplifies to 2/5. Okay? Either one will work. Okay? Now the last thing that I have here, or the next thing I should say, is linear versus exponential. So does each table represent a linear or exponential function? So as we are learning some more of these functions, that's what we're going to have to do, is identify, well, what kind of function is it when given the table or the graph or the equation? So for our first example, what we're going to go ahead and do is see how much it changes. We add 1, add 1, add 1. For our y's, we could add 2 or multiply by 2, but then from 4 to 6, we would have to add 2. 6 to 8, add 2. So our focus right now is to add 2 each time. So when we are have a constant rate of change like we do right here, okay, I'm going to know that this is linear. I'm adding or subtracting each time, so this is a linear function. Then we do our slope. So a quick reminder, slope is the change of y over the change of x. And we're going to write it in slope-intercept form. Slope-intercept form is y equals, then we do our slope. My slope is 2 over 1, or just 2, x. Then we write down our y-intercept. When x is 0, y is 2. So we have plus 2. Okay. Let's go below to the next one. So again, let's see how it changes. Our x-coordinates, we add 1 each time. Our y-coordinates, We're subtracting 4, subtracting 2, subtracting 1, but that's not a constant rate of change. But what I can notice is I can multiply 8 times 1/2, 4 times 1/2, 2 times 1/2 to get the previous. And so now I have a constant ratio, okay? That constant factor that we multiply by. And so this tells me that this is exponential. And just a quick reminder, we need to write down the first term. The first term is going to be 8, or our y-intercept. Our constant ratio is going to be 1/2. So when I write this equation, f of x is equal to 8 times, I'll just go ahead and have that in parentheses, 1/2 to the power of x. And again, that 1/2 does need to be in parentheses. We'll do the next two the next time I see you in class. And then the same thing with this one. We'll go ahead and do this next time I see you in class. Real quick, I forgot to put this line in here, so we can go ahead and stick that line in, and we'll label that as y. So, alrighty, that's it for these notes. I'll see you next time in class.